Hey everyone, Make is a utility for building projects. These can be programs or program libraries, but they can also be, for example, collections of corpora. And it's especially good at automating building for projects with a large number of files. So let's start working with Make. And to get going, let's look at a project which I have set up. And this is going to be a project which processes a number of Gutenberg books into corpora and frequency lists. And the reason why we want to use Make is that we're going to need several scripts for transforming these books into corpora. And we also need to run them in the exact same way for each of these books. So it makes sense to automate the running of the scripts. And this means less work in the end and also less errors during the conversion process. So I'm currently in a directory called Gutenberg Books. There are 3 subdirectories here. A data directory, and let's look at it using ls. It has 10 Project Gutenberg books in there. Then we have an src directory for source. It has 3 scripts in there. A remove Gutenberg metadata.py, which is a Python script for removing the Project Gutenberg header and footer from the books. Then we have a script called send_per_line_sh, which transforms each book into sentence per line format. And then we have a freqlist.sh script, which computes a frequency list of the words in the text file. And then the last directory in this Gutenberg Books directory is results, and that one is currently empty. And this is going to be the directory where we're going to place the corpora and frequency lists that we create. Okay, so let's start by just stepping through this conversion from book to corpus and frequency list one command at a time. I'm going to go into the data directory. Now let's look at this lifeofb.txt file here. So one of these 10 books that we're going to process is Life of B. It has this Project Gutenberg metadata, and we'd like to get rid of that. So let's quit using Q. So the first step is to apply this remove Gutenberg metadata.py Python script in src. And that one we're going to apply in the following way. So Python 3, and then the path to the script, which is one directory up, then in the src subdirectory, and remove Gutenberg metadata.py. And then the input file, which is lifeofb.txt, and the output file, which we're going to call lifeofb.nomd md.txt, md for metadata. And then just enter. Okay, so let's look at the result using less. So less lifeofb non-md.txt. And now we can see that we don't have this header anymore. So that's been removed. Let's quit using Q. Okay, so then we have these 2 separate tasks. We need to feed the nomd file to the freqlist.sh to produce a frequency list, and then to this send_per_line.sh script to produce a sentence per line file. So both of these are used in a very similar way. Then we have these 2 separate tasks. We need to feed the nomd file to the freqlist.sh to produce a frequency list, and to send_per_line.sh to produce a sentence per line file. So these are used in a very similar way. So we just give the path to the script, up 1 level, src subdirectory, and freqlist. Then the input, which is lifeofb.no_metadata, and then the output, which is going to be in the results subdirectory. So lifeofb rec.txt. And now we can quickly look at this one to see that it's the same, or it's what we expect it to be. So life of e.frec.txt, and look at it using less, and that looks like a frequency list. And then this sent per line.sh is going to be used in pretty much the same way. So path to the script, src, send per line, and then the input will again be life of b dot nomd.txt, and the output will be life of b dot send.txt. And then we can look at the resulting file. And it looks like sentence per line format. Okay, so I'm going to remove the files that we just created. So there's life of b.nomd.txt and everything in results, so that we can recreate them using make. And then I'll get out of this data directory, and now I'm going to use Nano to create a file called makefile here in the Gutenberg book directory. So these files which tell make what it's supposed to do are always or usually called makefile with an uppercase N, and usually don't have more than one in each directory. And a very simple makefile can basically look like the following. So we have a target like data life underscore of underscore b dot no md.txt. This is the file that we're interested in creating. And then a colon. And then we have a list of requirements, which are the input files, or input file in this case, that are needed for producing this target file. And in our case, the nomd file is just produced using the regular text file. So let's just write data life of b.txt. And then below, we have a recipe for creating the output file from the input. And I'll write this in a very simple way first, and we'll soon see how to make all of this a little bit more powerful. So Python 3 src remove Gutenberg metadata.py, and then data life of b.txt is the input file, and data life of b.nomd.txt is the output file. Okay, so let's save and exit Nano. And then run make. And it'll run for a very short time. And if I list the contents of the data directory now, I can see this no metadata life of b here. So let's open the makefile again using Nano. Now there are some nice variables that you can use in order to avoid typing so much in your makefile. In this make target, I can refer to the first input file using $. So instead of writing data /life of b.txt here in the recipe, I can just say $. And make will know that $. refers to this input file, the first input file in this list of dependencies or requirements. And likewise, I can also refer to the output file, lifeofb.nomd.txt, using $@. And make will know that this refers to the target file here. So let's check that this gives the correct result. So let's save and exit. And then run this make again. Now this says that lifeofb.nomd.txt is up to date. And we'll get back to what that means exactly shortly. But it basically means that because we already have a lifeofb.nomd.txt file in the data directory, make is not going to remake it. So make is very economical in the sense that it never recreates a file which it doesn't have to recreate. And just to test this, let's remove the existing file and remake it. So rm data lifeofb.nomd.txt. And then just say make data lifeofb.nomd.txt. And this time make creates the file because it didn't already exist. Okay, so let's get back to Nano. Now, as I said in the beginning, the reason why make is so useful is that it can automate the build process for a whole lot of corpus files, which are created in the exactly same way. Now, our current target is a little bit silly because it only builds for a single specific file, lifeofb.txt. So now we'll see how you can generalize this to build a NoMD file for any Project Gutenberg book. And the idea is to use patterns. So let's look at the input and output file here, lifeofb.txt and lifeofb.nomd.txt. We can see that this data /lifeofb part is exactly the same for both. So we can generalize this using the following syntax. We just replace the identical parts with percentages. And the idea is if someone asks make to create a file lifeofb.nomd.txt in the data directory, it checks this target and sees that this target could be used for creating the file, provided that there is a lifeofb.txt in the data directory. And if it finds this file, it will then happily generate the NoMD file. So let's try this one as well. So let's save and quit Nano. And now let's remove this data lifeofb.nomd.txt. And then we can just remake it. And now because we generalized our target, we can also run the same thing for the file Alice. So let's create an alice.nomd.txt. And that works equally well.